Hello everybody, today we're going to talk about solving quadratics using a different method, using an operation that we call square roots. So just a quick reminder, quadratic, remember, will always have a highest exponent or degree of 2. And there are different forms of quadratics. One of the more popular ones that we've talked about is what we call standard form, ax squared plus bx plus c. We're going to set that equal to 0 to make it an equation. Also remember that a quadratic will have at most 2 solutions. So it could have no solutions, it could have 1 solution, or it could have 2 solutions. And the different names for those are solutions, roots, zeros of the functions, and also x-intercepts. Okay, so today we're going to talk about using square roots. So we're going to use square roots to solve quadratics in the form ax squared plus c equals 0. So if a quadratic can be written in this form, and it's in standard form, then we can use square roots to solve. Now the idea here in this form is that there is no bx term. So essentially the value of b is 0, canceling that out, leaving you with ax squared and the constant set equal to 0. Okay? So for these problems, again, we can get 2 solutions, 1 solution, or possibly no real solution. So let's look at a couple examples. So in our example, the directions will just say solve, and we will be given the example 3x squared minus 27 equals 0. Now, one thing you want to recognize from this problem is that in this problem, there is no bx term. So as soon as I see that in my head, I am automatically thinking about square roots. Okay, so in order to use the square root method, the first thing that you need to do is you need to isolate x squared. So to do that, I'm going to add 27 on both sides, leaving me with 3x squared equals 27. And again, I want to get x squared by itself, so I'm going to divide both sides by 3, giving me x squared equals 9. So let's think about this. In order for x squared to equal 9, think about what 2 values x could possibly be. Well, x could be 3, because if x is 3, 3 squared equals 9. The other option, though, is that, well, it could be negative 3. If you take negative 3 and square it, you also get 9. Okay? Now, whenever we solve equations, what we do to get what we want and where we want it is we do inverse operations. Like I did the inverse of subtracting. And then over here, I did the inverse of multiplication, which was division. Now, to get rid of this squared, or this power of 2 exponent on my x so that I just have x, I'm going to do what's called square rooting. And that is because the square rooting is the inverse operation of squaring. And vice versa. Squaring is the inverse operation of a square root. So square rooting and squaring have the same relationship as adding and subtracting and multiplying and dividing. So if I'm going to square root, so if I have this x squared and I want to undo the squared by square rooting, because this is an equation, I have to also square root the other side. So I have to square root the 9 as well. So what we have to do is not only square root, but we need to square root both sides. And it's not square rooting individual terms, it's square rooting a whole entire side. Now if I square root x squared, I just get x. And if I square root 9, I get 3. But remember this over here that we talked about what the solutions would be before we actually solved it. We determined that the solutions would be 3, but it could also be -3 to get the right answer. And also there could be at most 2 solutions. So that means not only is 3 a solution, but -3 is also a solution. So what we're going to do is anytime that we square root both sides, we have to think about the two different options of the positive and the negative. So we're going to put a plus or minus sign with our number side of our equation. That way it takes care of both the positive 3 answer and the -3 answer. So again, when you square root both sides, you must put that plus or minus sign, because otherwise you're not considering both answers. So again, this idea of writing a plus or minus 3 is the same. So saying x equals plus or minus 3 is the same as saying x equals 3 or x equals -3. You do not need to write it out like this, but you do need to understand that this symbol here, writing plus or minus 3, is a shorthand way of writing this. Okay, let's go to the next example. Let's try x squared minus 10 equals -10. So again, we're going to isolate x squared by adding 10 on both sides. That gives me x squared equals 0. Square rooting x squared, square rooting 0. I get the square root of x squared is x, and the square root of 0 is technically plus or minus 0, but is there a positive and -0? No, there is only 0, and therefore you get x equals 0 as your only solution. Remember, you can get 2 solutions, 1 solution, or no real solution. So in number 3, we have -5x squared plus 11 equals 16. On this problem here, we want to go ahead and subtract 11 on both sides in order to start isolating the x squared, and then dividing both sides by -5 will give me x squared equals -1. So when I go to square root, in order to undo the exponent of 2, I must also square root the other side, not forgetting my plus or minus. I'm going to put it over there also. When I take the square root of x squared, I get x. Now, if we think about what number could we multiply to itself to get -1, well, there's actually no value of x that if you square it, that you're going to get -1. That's not going to happen. So for this problem here, this would be where you would get no solutions. And I'm going to write it a little bit more specific and say no real solutions. When you get to higher levels of mathematics, you come to understand that there are solutions, they're just not real solutions. So anytime you are square rooting both sides and you get a negative number under the square root, this is going to be your answer. Your answer is going to be x equals no real solutions. So I gave you an example where you get two solutions, one solution, and no real solution. Let's look at one other type of example. Sometimes it's not just a number that's squared, but it's a binomial that is squared. So in this problem here, we have a binomial that is squared. Okay? You do not need to take that and write it out and then multiply it. It's not really necessary to do all of that work because there is a quicker method of solving this. Anytime, so I'm not going to do that. Anytime you have something squared equal to a number, whether it's just a variable or it's a binomial, you can always get rid of that power of 2 by square rooting. So in my next step, I'm going to go ahead and take that binomial squared and I'm going to square root it. Okay, and then that means I have to also take the other side, which is 25, and square root it, not forgetting the idea that I could get a positive or negative value solution there. Okay, now if you're not sure what the square root of x minus 1 squared is, well, think about it this way. If you have the square root of x minus 1 times x minus 1, well, there's a pair right there, so it comes out as an x minus 1. Remember what a square root does is it literally undoes or cancels out the squared. So what the square root does is it takes this and it cancels it out, leaving you with just x minus 1. On the other side, I get plus or minus the square root of 25, which is 5. So in this problem here, what we now have is we have x minus 1, which we now need to get rid of the minus 1. On the other side, we have two values. We have a plus 5 and we have a minus 5. So what we can now do is we can add 1 on both sides. And do I add 1 to the positive 5 or do I add it to the negative 5? Well, let's look at that further by just writing them side by side. So if you're ever not sure if you should combine something, just write them side by side. And what you end up with here is you have two different options that are going on. This right here is a representation of x equals 1 plus 5. It's also a representation of x equals 1 minus 5. Because remember that plus or minus 5 means you have a positive 5 and you have a negative 5. So splitting it up and seeing that I still am going to get those two solutions. My solutions are going to be what I get from 1 plus 5, which is 6, and 1 minus 5, which is negative 4. And then there is your final answers. Both of those solutions would work, and you can always check your answer by plugging it back in to see if it works. Okay, one last example. We have 2 times x plus 4 to the power of 2 equals 16. Now, just like if I had 2x squared equals 16, what I would want to do is I would want to get this x squared by itself. Well, I don't have just an x squared, I have a binomial squared. So in this case, what I'm going to do is I'm going to isolate the binomial squared. Okay? And I'm going to do that by dividing both sides by 2. If I divide both sides by 2, I get x plus 4 to the power of 2 equals 8. And again, the way that I undo that power of 2 is I'm going to square root And I'm also going to square root the other side, not forgetting my plus or minus. Now the square root of x plus 4 to the power of 2, this will cancel that out, leaving me with just the binomial x plus 4. On the other side, I have a square root of 8. Remember that 8 breaks down to 4 times 2. So square root of 4 is 2. And the square root of 8 is 2 root 2. Please no decimal answers. Please make sure that you always simplify your radical. My last step here is going to be to subtract 4 on both sides to get x by itself, leaving me with x equals. Now over here, we need to remember here that we can't combine numbers with square roots. So terms that are just numbers and terms that have square roots cannot be combined. So we literally just write them side by side. It's the idea that if you have 3 plus the square root of 2, it's not equal to 3 times root 2. Those are not the same thing. So don't make this mistake. So what we're going to do is we're just going to write it -4 plus or minus 2 root 2. Now you don't need to split this one up like we did the last one because these are not like terms. The reason why I split these up into 2 separate little operations is because they were like terms. But you still have 2 solutions here. Your solutions are -4 plus 2 root 2. Your other solution would be -4 minus 2 root 2. And if you wanted to see what those approximate values were, you could put them into the calculator and get an idea of exactly where your graph would cross the x-axis. Okay, so I hope this video helps you, and best of luck with your practice.